Dear students, welcome back to our lessons. Today I'm going to cover simultaneous equations, linear quadratic. This is a paper A topic suitable for the paper A syllabus. So linear quadratic, simultaneous equations. The scope of this topic is also to solve two equations, but this time they are not both linear equations. One is a linear equation, the other is a quadratic equation. We're still going to have two unknowns, x and y, but this time we might have more than one answer for x and one answer for y, and I'm going to explain why this happens. This happens because when we're solving simultaneous equations, it's the same thing as when we're drawing two graphs simultaneously on the same page, and then we see where those two graphs meet. So, for example, if we're solving two linear inequalities, graphs, we're going to have something similar to this. If they are both linear, we're going to have two straight lines, for example, line A and line B. And the point of intersection is the solution of the two lines. So we have x and y, the solutions, which are the solutions of both equations. So x satisfies both equations and y, the same value, satisfies the same equations. Now, if we have one linear and one quadratic, we're going to have varying solutions. So, for example, I can have a quadratic equation of the form y equals ax squared plus bx plus c. And I want to have a straight line. So let's consider a straight line now. A straight line which can do the following. So a straight line can pass. So this is straight line y equals mx plus c. These two equations meet at two distinct points. So if we find where they meet at this value here. So there's a value for x and a value for y. And they meet also at this point here. So we have a value for x here and a value for y here. But when we have one linear and one quadratic, in this case they met twice. It might be the case that they meet once. Let me show you an example. So there is my quadratic equation, y equals ax squared plus bx plus c. And here is my line, the line y equals mx plus c. As we can see in this example, the two graphs met only once. So we have one answer for x and we have one answer for y. That's because the line now is a tangent to our curve. It can also happen that they will not meet. Let me show you an example. This also might be the case. I have the graph of y equals ax squared plus bx plus c. And I have a line, a straight line. And now the two graphs did not meet. Y equals mx plus c. As we can see, that they did not meet, meaning there is no solution. So I can have two solutions, I can have one solution, I can have no solution. Of course, when we say linear quadratic, I also mean when one of the curves, one of the equations not the straight line one, but the other one, can be an inverse curve. So we might have something similar to this. I have the curve y equals a on x, and there is a line. There is a line y equals mx plus c. Now, let's consider this line y equals mx plus c. Again, this line met the curve at two distinct points, one for x and one for y, another one for x, another one for y. So in this case, we shall have two different answers for x and two different answers for y. But if our line passed somewhere in between, or if our line passed just tangentially to one of the two curves, we would have either one equation, let's see, let's consider another line. This time it is tangential. Okay, so it met here. So I have an answer for x and an answer for y. This is the line also y equals mx plus c. But our line could have passed somewhere in between without meeting any of the curves. So there's our line y equals mx plus c. This line, this time, didn't meet the curves y equals a on x. So in this case, there will be no solution. Okay, so this is what's going to happen when we're solving these equations. This is visual representation of what's going to happen now. I'm going to use algebraic methods to solve these equations. So the method that is going to be used to solve linear quadratic simultaneous equations is the method of substitution. So this time we're using the substitution method. The elimination method, which we used when solving linear simultaneous equations, will not work in this case because we can't eliminate a square. So let's consider the following example. Let's suppose I have solved x squared plus y squared equals 5 and 3x plus y is equal to 7. So if I need to solve those two equations, I have equation number 1 and I have equation number 2. What am I going to do? We're going to choose one of the two equations. When we're going to choose one of the variables, make that variable subject of the formula, and substitute the answer into the other equation. Now, we have to choose wisely. In this case, I notice that the linear equation is 3x plus y equals 7. So it's normally the easier one to choose. And I am noticing that y has a coefficient of 1, meaning that it's very easy to make y subject of the formula. So in this case, I'm going to choose y, and I'm going to make y subject in equation 2. So I have 3x plus y is equal to 7. So y is equal to 7 minus 3x. Now, that I know what is y, and this is now equation 3. Once I know what's y, I'm going to substitute y into equation 1. So substitute equation 3 into equation 1. So let's substitute. I have x squared plus y squared. So 7 minus 3x squared equals 5. I am going now to open up this bracket. Notice that now I have eliminated y. So x squared plus 7 minus 3x squared is equal to 5. I'm going to open up this bracket now. So I have x squared plus 7 sevens are 49. Minus 21 is minus 42x plus 9x squared is equal to 5. Now we have formed a quadratic equation. I'm going to continue on this side of the page. We have formed a quadratic equation. I'm going to place everything on one side is equal to 0. So I have 10x squared minus 42x plus 49 minus 5, so plus 44 is equal to 0. As I can notice here, I have a common factor which is 2, so dividing by 2, I get 5x squared minus 21x plus 22 is equal to 0. Now that we have arrived here, we need to further factorize this equation. Now, here you can either use the formula, x equals minus b plus or minus square root b squared minus 4ac onto a. In that case, a is 5, b is minus 21, and c is 22. Or otherwise, change this trinomial into 4 terms and then group to find the factors. I'm going to use the second method. So, multiplying 5x squared by 22, I get 110 x squared. 2 factors, I'm going to find 2 factors of 110x squared, which when added give minus 21. And as we can see, 11 times 10 is 21. So minus 11x minus 10x is minus 21x. So I'm going to substitute minus 21x by minus 11x minus 10x. So I get the following. 5x squared minus 10x minus 11x plus 22 is equal to 0. So here, now I can grouping these two and then grouping these two. I'm going to get the following. 5x is a common factor, leaving x minus 2. Minus 11 is a common factor, leaving x minus 2 is equal to 0. So I have x minus 2 into 5x minus 11 is equal to 0. So x is 2 and x is 11 on 5, or 2 1/5, 2.2. Now that I know what are the values of x, I can find the value of y. So, last part of the problem, when x is 2, I am going to choose equation 3 and substitute into that equation. When x is 2, y is 7 minus 3 times 2, that's 7 minus 6, 1. And when x is 2.2, y is going to be equal to 7 minus 3 times 2.2, which is 7 minus 6.6, which is 0.4. So we have got the two answers, which are 2, 1, and the other answer 2.2, 0.4. As we can see, there are two pairs of coordinates where those two graphs meet. This is the first example. It was a very straightforward example. Of course, you need to know your algebra well to be able to finish out the problem, but that's up to you. Now, the second example, we're going to work another example so that I'll show you some practice of these. So let's work out another example. Solve. X squared plus xy equals 10 and x minus 2y equals minus 4. Again, as in the other problem, I'm going to try to make a subject of the formula an equation which seems to be the easiest one, and I'm going to choose the letter which gives the least trouble. Now, there is x squared and x, so I have to substitute twice. There is y, I have to substitute once. But this is the equation 2 is the easiest equation, and as I can see, x has a coefficient of 1. So I'm going to choose this equation, and I'm going to make x subject of the formula. So I have equation 1, and I have equation 2. So I'm going to make x subject in equation 2. Making x subject will get x equals 2y minus 4. Now, and that's equation number 3. We're going to substitute now equation number 3 into equation number 1. Since we chose 2 first, 3 into 1, okay? So I get 2y minus 4 squared plus 2y minus 4 multiplied by y is equal to 10. We have eliminated x. Now, I will have to open up brackets and solve for y. So we get 2y minus 4 times 2y minus 4 plus 2y squared minus 4y is equal to 10. So I have 4y squared minus 16y plus 16 plus 2y squared minus 4y minus 10 is equal to 0. For y squared, I'm going to collect like terms. 4y squared into y squared is 6y squared minus 16y minus 4y is minus 20y plus 16 minus 10 is plus 6 is equal to 0. Again, this time we have two common factors. Since it's an equation, I can divide by 2. Dividing by 2, I get 3y squared minus 10y plus 3 is equal to 0. Again, I'm going to factorize that. I'm going to continue on the other side of the page. So, multiplying again 3y squared by 3, I get 9y squared. I'm going to find two factors of 9y squared, which when added give minus 10y, the term in y in this case. So 9 times 1 is 9, 9 plus 1 is 10, so minus 9 minus 1 is minus 10. So I get 3y squared. I'm going to substitute minus 10y by minus 9y minus 1y plus 3 is equal to 0. I am going to grouping these two and then these two, so I get 3y into y minus 3 minus 1 into y minus 3 equals 0. Remember that when grouping, the two brackets should be the same. So I have y minus 3, this time common factor, into 3y minus 1 equals 0. So this time y is equal to 3 and y is equal to 1/3. We got the two answers for y. Now we're going to substitute these into equation 3. So substituting, mela when y is 3, x, which is 2y minus 4, is going 2 times 3 minus 4, 6 minus 4 is 2. And when y is 1/3, x 2 times 1/3 minus 4, which is 3 and 1/3, or 10 on 3. So we got the two answers now. The answers are 2, 3, and the coordinate 3 and 1/3, minus 3 and 1/3, 1/3. So those are our two answers. This was another equation, another problem. It wasn't too much different from the other one, but this time we had to substitute twice our subject, okay? So, let's do another example, slightly more difficult than this one before doing two problems, because you might have problems where first you need to find the two equations and then solve them, so they will have more marks, they will be slightly more difficult. So, next example. Solve x squared minus 2xy equals minus 1 and 2x minus 3y is equal also to minus 1. So now this time we have the two equations, equation 1 and equation 2. As we can see, equation 1 is the quadratic equation. Equation 2 has x and y, but unfortunately this time in front of x and in front of y the coefficients are not 1. 1 is 2 and 1 is 3. So we're going to choose one of the equations to substitute. I suggest you choose the equation with y. I'm going to make y subject. Why? Because if I make y subject, I'll only substitute once into equation number 1. If I make x subject, I have to substitute twice. So I'm going to make y subject in equation number 2. I get 2x plus 1 is 3y. So y is 2x plus 1 on 3. Now we've got a fraction. We have to be very careful, okay? So this is our third equation. I'm going to substitute equation number 3 into equation number 1. So I get the following: x squared minus 2xy, which was 2x plus 1 on 3, is equal to minus 1. Now, in our first step, we're going to eliminate the denominator. Now, that's an equation, so I can multiply throughout by 3. Multiplying by 3, I get 3 there, I get 3 there, I get times 3. And what happens? This 3 cancels out. So now I get 3x squared minus 2x times 2x plus 1 equals minus 3. Open up this bracket, I get 3x squared minus 4x squared minus 2x equals minus 3. I'm going to place everything on the other side of the equation so that I get x squared positive. So I get 0 equals x squared plus 2x minus 3. This is a simple now trinomial. So I get x and x, 3 and 1 plus and minus. So x equals minus 3 and x equals 1. We got the two values for x. Now we need the values of y. So when x is minus 3, we're going to use equation number 3. Y is equal to times minus 3 plus 1 on 3. That's minus 6 plus 1 minus 5 on 3. That's our first answer. And when x is 1, y is 2 times 1 plus 1 on 3. And 2 times 1 plus 1 on 3 gives 1. So those are our two answers. So we have minus 3, comma, minus 5 on 3, and the other solution 1, comma, 1. As we have seen in all these examples, we always had 2 points of intersection between the two equations. Now let's consider a couple of problems. Start our problems. The first problem the sum of two numbers is 5. The sum of their reciprocals is 5/6. Form two equations. And solve them to find the two numbers. So in this case, we're going to start by defining our two numbers. So I'm going to say, let one number be x and the other y. So I'm going to have the sum of the two numbers is 5, meaning that x plus y is equal to 5. And that is our first equation. The sum of their reciprocals is 5/6. So the reciprocal of x is 1 on x, of y is 1 on y. The sum of the reciprocal is 5 on 6. And that's equation number 2. Now, as you can see, in this equation, we've got an algebraic fraction, meaning that we must first simplify that, or we can also substitute, but come what may, we need to simplify that algebraic fraction, and that's what I'm going to do first. So, if I have 1 on x plus 1 on y is 5 on 6, I am going to multiply this equation by the LCM x, y, and 6xy. Multiplying 1 on x by 6xy, x is eliminated, we get 6y, plus multiplying 1 on y by 6xy, y is eliminated, I get 6x, equals multiplying 5 on 6 by 6xy, 6 is eliminated, and we'll get 5xy. I'm going to call this equation number 3. So now we got x plus y is 5, and 6y plus 6x is equal to 5xy. Now, the simplest part is now I'm going to choose x or y to substitute into the equation. It doesn't matter which one I make subject, so I'm going to choose x. So I'm going to make x subject, in equation 1. So I get x is equal to 5 minus y, and I get equation 4. Now I'm going to substitute equation number 4 into equation number 2. Okay, so I get equation number 3, sorry. So I get 6y plus 6x, which is 5 minus y, equals 5x, y, and x is 5 minus y. Multiplying, I get 6y plus 30 minus 6y, this is equal to 25y squared minus 25y minus 5y squared. So let's continue on this side of the page. So I'm going to place everything on one side of the equation. So I get 5y squared plus 6 minus 6 is eliminated, so minus 25y plus 30 is equal to 0. I'm going to divide by 5 because 5 is a common factor in this case. So I get y squared minus 5y plus 6 is equal to 0. This is a simple quadratic equation. So I get y and y, 6, 3 and 2, so minus 3 minus 2 equals 0. So y equals 3 and y equals 2. I've got the two answers for y. Now just simple substitution into equation number 4. So when y is 3, x is 5 minus 3 and x is 2. And when y is 2, x is 5 minus 2, which is 3. So my two numbers are 2 and 3. 2 and 3 are the two numbers. So that's the first problem. It was quite straightforward, nothing to hide, nothing hidden. But now I'm going to work out another problem which is slightly more difficult. So problem number 2, I'm going to have a rectangle. This rectangle has length and breadth x and y. The area of the rectangle is 50 square meters. Its perimeter is 30 meters. Form two equations. Hence, solve them to find the values of x and y. So, we've got two pieces of information. The first piece is that the area is 50 square meters. The second is that the perimeter is 30. So, this is the first part of the problem, and this is the second part of the problem. So let's take the first part of the problem. The area is 50. Area of triangle is length times breadth. So xy is 50, and that is our first equation. The perimeter is 30. The perimeter is 30 means that half the perimeter, x and y, is 15. So x plus y is equal to 15, or you could have come out with 2x plus 2y is equal to 30. It's the same equation. I have divided by 2. So now I have got one equation and the other equation. I'm going to choose equation 2, and I'm going to make x subject of the formula. So I'm going to make x subject in equation 2. I get x equals 15 minus y. And that is equation number 3. Now I'm going to substitute equation number 3 into equation number 1. And I get x, which is 15 minus y, times y is equal to 50. So 15y minus y squared is equal to 50. So 0 equals y squared minus 15y plus 50. That is a simple trinomial again. So 0 equals 2 brackets, y and y, 10 and 5 both are negative. So y is 10 and y is 5. I've got the two answers for y. Let's get the two answers for x. So when y is 10, I'm going to substitute that into equation number 3. X is 15 minus 10, x is 5, and when y is 5, x is 15 minus 5, that's 10. Alright? So x and y, the length and breadth are 10 and 5 meters respectively. So that's the end of this topic, linear quadratic simultaneous equations. I hope you have understood.